Hi, everyone, and welcome to week 2 of MAT 205. This week, we're going to be working with permutations and combinations. So I thought I would just make a little video showing how to kind of get through these. So hopefully this will help. All right, I'm going to switch to my old school camera. All right, so welcome to week 2. So we're going to start off with factorial expressions. So you might see it as something like here, 7 and it's an exclamation point, and 8 exclamation point over 5 exclamation point times 9 exclamation point. So they might give you a problem like this. In fact, I'm pretty sure they will, and ask you to simplify your answer as much as possible. So there's a whole definition of factorials right here, but instead of kind of looking deeply into the eyes of this, I thought maybe we could just get into what it actually means here with actually working the problem out. So see what they've done in the numerator. They did the 7 with the exclamation point, so they put that here. And they multiplied that times that other number up here, 8 factorial. And then they separated the bottom 5 factorial and 9 factorial. Now, you don't necessarily have to separate the tops and the bottoms as far as like if there's two numbers next to each other. You just kind of have to know that they're multiplying to each other, okay? But what does this mean? Well, when you see a 7 and an exclamation point, you're just going to write 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's all times 8 factorial, which is just written out 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you have all of that. And if you want to, you can just do it in one big numerator. And then on the bottom, we have 5 factorial, which is just 5 times 4 times 3 times 2 times 1. 9 factorial, you can kind of see is 9 times 8 times 7. So whenever you see that number with the exclamation point, it just means take that number and expand it out using multiplication and go all the way down to 1. Then what's kind of fun about these is you can start canceling like numerators and denominators from each other. So for example, like these 8s would cancel, the 7s would cancel, the 6s, the 5s, the 4, the 3s, the 2s, the 1s. Over here, your 4s would cancel, 3s, 2s, and 1s. Your 5s would cancel. So you'd really be left with, if you kind of think about this, 7 times 6 up top and nothing else is left standing. And then down the bottom, you only have a 9. So really, this whole thing becomes 42, which is 6 times 7 or 7 times 6 divided by 9, which they simplified to 14/3. So this might seem kind of scary, but really, when you see something like 5 factorial, it's just a shortened representation of 5 times 4 times 3 times 2 times 1. All right, so let's get into it here. So I want you to try one. So you kind of saw how to write this out. So give this a try. I want you to pause the video and come back and see me. Okay, so if you're back, I'm not going to spend time separating this. I'm just going to go. So 6 factorial, of course, is 6 times 5 times 4 times 3 times 2 times 1. And then 4 factorial is, 4 times 3 times 2 times 1. And I'm just going to put them all together in one large numerator and just make sure I have multiplication in between. Because really, there is multiplication in between each of these. They're kind of snuggled up next to each other. On the bottom, we have 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And then, of course, writing it out is kind of a pain, but then the fun part happens after that, where you can start canceling. So I see things that I can cancel. Hopefully you were canceling these. I've got this 5s that cancel. It's kind of fun. Then you kind of see what's left. So 6 times 4 is left up top. Down below, I got nothing left. So really it's just a 1. So it's really 24 over 1 or just 24. Oopsie. Okay. So I think I give you another one to practice. So give that a whirl on the next slide. So feel free to pause the video and then come back and see if we match answers. Okay. So writing everything out, kind of a pain, but then the fun part, happens. the canceling, right? And the reason we're able to cancel is, you think about this, 4/4, let's say, for example, is just really 1. 3/3 is really 1. 2/2 is 1. 1 divided by 1 is still 1. So that's why we're allowed to just simply cancel this. And you might find that it's kind of relaxing to do this. Okay, so what's left up top? Hopefully you saw 5 times 4 times, I think 3 is still left there. My handwriting's terrible, but I think that's what's up there. And then I have down below, I think I've got 8 times 7. So 5 times 4 is 20. 20 times 3 is going to be 60. 8 times 7 is 56 on this planet still. So 60 over 8 times 7, which I don't think is 57, what I just wrote down. So that's not right. Okay, so now we have 2 even numbers, so we can always start by slicing them in half if you want. So of course, half of 60 is 30, half of 56 is 28, and then you can slice them in half again. Probably could have got there quicker if I just divided by 4, 2 times 2 is 4, but we're still gonna get there. We'll skin this cat still. So hopefully you got 15 over 14. So hopefully this is not too scary. Hopefully you're feeling good about what we got going on here. So let's take a look at what's happening next. Okay, so we're going to take those factorials that we just learned about, and we're going to go a little further and work with permutations and combinations. Okay, so these little formulas, like this expression here, it's called, these are little subscripts, like little subscript n, large P, little subscript r, just means the number of permutations of n things taken r at a time. It can be evaluated using this formula. So this formula is kind of something you're going to want to put in your notes and make sure you have that close by, because you're going to use it constantly. So that's a formula for permutations. So we're going to practice taking n things taken r at a time. And you'll see what that means here in a minute. The expression little n, little subscript n, large C, little subscript r just means the number of combinations of n things taken r at a time. So notice a permutation has a P in the formula. A combination has a C in the formula. And the formulas are pretty similar. You're going to kind of see that the permutation formula is actually hidden inside the combination formula, but the combination formula has a little extra something here. Okay, it's got that little R factorial. Okay, something else to kind of put in your notes is that by definition, 0 factorial is just 1. Also, we know that 1 factorial is equal to 1. So these are kind of like just rules that we have to live by. So it can be said that an empty set can only be ordered one way. So that's why 0 factorial just becomes 1. That's the explanation for that kind of weird little rule there. Okay, you might be asking yourself, what's the big deal? What's a permutation? Why would we need a combination? So let's play around with this. Okay, so a big deal to kind of keep in mind is that when you're working with a permutation, when you want to permute, the order in which you take the items matters. So here's the formal definition of permutations of n objects taken r at a time. So there's n objects taken permuted r or at a time. The arrangement of n objects in a specific order using r of those objects without replacement is called a permutation of n objects taken r at a time. It's written NPR, and it's calculated using this formula. So this is the formula that we want to keep handy kind of at all times, because we're going to be referring to that one. Okay, so an example, when would you use a permutation? Well, when order matters. So seating arrangements, seating or other arrangements, when you give out trophies for first, second, and third place, officers, when you have to line up officers like president, vice president, treasurer, secretary, etc. So these are examples of when you would use a permutation, because the order of the seating, let's just say, or the order of the trophies, or the order of the officers, it matters. Okay. Okay, so let's practice a permutation. Suppose we wanted to choose 2 objects without replacement from three objects, pencil, eraser, and desk. How many ways can this be done if the order of the choices is relevant or it matters? Well, we know if order matters or is relevant, we are going to use the permutation formula. So remember that formula that we circled a few slides back? We're going to break out the permutation formula. Okay, so let's do this problem. We want to choose two objects. So that's the set of objects, or we want to choose two from three different objects. Okay, so okay, so remember the n, this little baby n, is just representative of the things that you're going to be taking, and that little baby r is the number of times, or r at a time. So we are going to do 3 permute 2. So we're going to take from 3, which is the number of sets of objects, that pencil, eraser, and desk, and we're going to permute because order matters, and we're going to take it 2 at a time. So they said to choose 2 objects, so we're going to choose 2 objects. So once you have your n and your r in place, then you're going to just use this formula here. So essentially, we are asked how many ways there are of choosing 2 objects without replacement from the 3 objects if the order of the choices is relevant or does matter. Okay, so our formula, let's write this down. 3p2, 3 permute 2, that's right here, is going to be equal to, so n factorial. Well, n right here is the number of sets of objects, that's 3. And then on the bottom, we have in parentheses n again, so again, that's 3 minus r, which is this 2 here, n factorial. So this formula just says take n, which is the things that you're taking, right? For us, 3 objects. And the r just says we're going to take them 2 at a time. So whenever you see an n, you're going to replace it with your n. Whenever you see an r, you're going to replace it with your r. So now we know what to do. We have 3 factorial, and 3 minus 2 is 1 factorial. And now we're right back to where we started at this lesson. So 3 times 2 times 1 over 1. That cancels. 3 times 2 equals 6. So there are 6 ways that we could choose 2 objects from the pencil, the eraser, and the desk without replacement from these 3 objects if the order of the object matters. Okay, so I know this is a lot, so I've given you a practice permutation problem on the next slide. So there's no story, no word problem here. We're just going to straight up do 7 permute 5. So I want you to pause the video and make sure to put your n, okay, this is your n. If you want to put that here, here's your r. Put them into the formula and then go for it with what you know how to handle your factorials now. Okay, so if we're back, hopefully you paused, and I hadn't even finished this problem myself. So n is 7, so 7 factorial, that's this. And then n minus r, which is 7 minus 5 factorials in the bottom. So let's simplify this real quick. 7 minus 5 is going to be 2. And then it's game over. We know what to do now. So 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. Those cancel, which is great. And we have 7 times 6 times 5 times 4 times 3. If you multiply that out, you should get 2520. We'll see. I'm going to double check myself with my old trusty graphing calculator. So 7 times 6 times 5 times 4 times 3 is 2520. Okay, so hopefully you got that. All right, so that's a practice permutation. And because math, in the case of math, practice makes perfect. So I want you to practice another one. Just get real comfortable with permutations. So pause the video and then come back and see how you did. Okay, hopefully you got 6720, and hopefully you're feeling a little better about just what it means to practice permutations. And remember, this is where the order is. Sometimes they use the word relevant in ALEKS. I think about it as order matters. Okay, so that's permutations. Let's do a little summary of permutations. These are the key elements that we distinguish when we need to use a permutation formula. One, we need to find the number of ways to arrange a certain number of objects. Order matters, and once an object is used, it can't be used again. Okay, so when I see you next, we're going to start into combinations. So I'll see you in the next video.